Today on the Next, our guest is Jon Miller Schwartz, co-founder and CEO of Ultra. Ultra builds and deploys practical general-purpose robots for American warehouses. We cover a lot in this episode, including Ultra's mission to revolutionize industrial automation, specifically focusing on robots that can adapt to various tasks and environments without requiring extensive re-engineering. He also discusses the background of the company, their operational model, the progress that's been happening generally in AI and robotics, as well as Ultra's progress to date. We talk about their strategic focus on the e-commerce logistics space and why. We talk about some of the current projects that they've been working on and how they are interacting with their customers and involving them in the building process. And we also talk about the importance of data in refining robotic capabilities and the collaborative efforts within the industry to accelerate advancements. It's a great one, especially for me, who didn't have a lot of background in robotics coming into the show, and I'm excited for you to listen. But before we get started, I'm Jason Jacobs, and this is the Next. It's not really a show, it's more of a learning journey to explore how founders can build ambitious companies while being present for family and not compromising flexibility and control, and also how emerging AI tools can assist with that. Each week, we bring on guests who are at the tip of the spear on redefining how ambitious companies get built, and selfishly, the goal is for this to help me better understand how to do that myself while bringing all of you along for the ride. Not sure where this is going to go, but it's going to be fun. Okay, Jon Miller Schwartz, welcome to the show.
Thanks, Jason. Glad to be here.
Well, glad to have you. It's funny, we got introduced through Derek Haswell, who we both know, and the introduction was timely because every now and again in my updates, I talk about robotics as an area that I'm looking to understand better. And here you are, a founder that is smack in the middle of what's happening in the trenches with robotics. So I'm psyched to have you on and learn more about Ultra and about robotics more generally.
Yeah, absolutely. Excited to chat about it.
To kick things off, maybe just talk a bit about Ultra and what it is.
Sure. At Ultra, we are building what I like to call practical general purpose robots. So we're focused on building robots that solve one specific problem today fully, but over time we can use to solve other tasks, other problems with the same exact robot. This is fundamentally different from what robots have historically looked like. When you walk into most factories or warehouses, you'll see kind of industrial automation. And those types of systems are usually very customized to the specific warehouse or the task that it's doing. And so every time you want to make a change or something changes in the environment or the items that the robot's interacting with, you need to call in the engineers and they need to go and re-engineer the robot, either the hardware, the software, or both. But we're now living through this moment due to a lot of the progress in AI, where we can actually build robots that can constantly adapt and be flexible to changes in environment or task or the objects that they're manipulating. And so it's super exciting to be working in robotics today because we can really see this opportunity to go and scale the number of robots that are out there in the world.
What is it about AI that makes that possible?
Yeah, so all of this is really based on the same underlying innovations that have enabled ChatGPT and other LLMs. To get a little technical, basically the transformer neural net architecture, which was pioneered at Google and OpenAI, then realized could be applied to language to create the LLM. It basically takes in language, so text from the internet, and breaks it down, and from there is able to predict the next part of a word, or eventually, if you play that out, many words, many sentences, many paragraphs. And so that is how an LLM works. And if you think about that, if you swap out the text for, let's say, robotic data, so the positions of a robotic arm over time, you can actually apply that same type of neural net prediction to robotics. And so instead of predicting language, we're actually predicting the position of a robot and what it should be as it interacts with the world. And so the inputs, maybe rather than a prompt, are a camera feed or tactile sensors or in some cases a prompt, like a task that you want a robot to do. And so this basically means that we can now have robots that are trained with data instead of needing to be explicitly programmed by engineers who have robotics degrees, let's say.
And where did the idea for Ultra come from? And start back as far as you want or as recent as you want. Up to you.
Sure. Yeah. I mean, a little background on myself. Ultra is my third company. I guess you can call me a serial entrepreneur. That's never been my goal.
Serial with an S, not with a C, right?
Exactly. Yeah. I studied engineering in undergrad, Harvey Mudd in Southern California. And I always was passionate and excited about building robots. In high school, I was on my first robotics team, if you know what that is, at the nationwide kind of robotics competition. And in college, I continued working on robots. Harvey Mudd, we had an underwater robotics team, which is significantly harder than building robots on land because everything has to be watertight, but a ton of fun. And anyway, ended up starting my first company right out of college. Not robotics, though. We were actually writing software for 3D printers. This was back in 2012, 2013, right as the 3D printing market was exploding. And started a company, knew nothing about how to build a business or really even how to build product. But through that experience, learned, I'd say, the foundation of what I know today. And we ended up selling that to MakerBot, which you may remember was leading that boom in the 3D printing space. So that brought us back to New York City. Spent some time there, and then we started our second company, actually myself and my co-founders. So Ultra is the third company we founded together. Well, yeah,
you guys are like an old married couple of entrepreneurs.
That's literally what it feels like, but it's great. It's like there's no other team I'd rather be working with. And so our second company, it was called Voodoo Manufacturing, and we basically built a high volume 3D printing factory. We asked ourselves what would happen if we took a lot of these printers and tied them together with software and with robotic automation to build a factory that could compete with overseas injection molding, but here in the United States. And really the goal was to build like AWS for manufacturing. So a software-driven factory, a software-driven process where you could just like easily scale up production of any part and iterate on that part without the kind of sunk costs of a mold, which is what most traditional manufacturing requires. And at Voodoo, we built a high volume plastic part factory. And there we experienced firsthand how hard it was to get robots to do useful things reliably. And so we built robotic systems in our factory to automate various like manual tasks that were highly repetitive. And we did it. And it was super cool when we finished these robots because they would just give our factory a superpower essentially. But if anything changed, literally during the season changes, when the temperature shifted and the whole building would like warp slightly, the system would stop working. And so that was how brittle we're talking about for just like generally robotics. And that experience, I'd say, was really fundamental to us and our desire to actually have had like more flexible robots that could easily be adapted to different tasks and locations in our factory. And yeah, that experience, plus just over the past few years, paying close attention to what's been happening in AI space and in the robotic space, basically made us feel like now is the most exciting moment when we can actually go out and build these amazing new types of robots that can really, in our view, enable, factories and warehouses in the United States unlike they've ever been enabled before through automation.
And it sounds like what's now, I'm going to say this as a statement, but that's just my way of asking a question and making sure I understand it right. But it sounds like what's now becoming possible because of AI is more versatility, where if there's different tasks that come at it or as the conditions change around it can sense what's happening or what's needed and adapt so that it doesn't start this domino chain of effects where it's in order to change that, this needs to change by this person, which then pulls them off of this task, which then means that this doesn't get done, it can just be smart and adapt in real time without screwing anything or setting anything else off kilter. Is that right?
Exactly. So I would actually say, so there are two things kind of like this new method of AI-based control allow for. So the first is what you're describing, which is essentially automating tasks that are unconstrained and even can occur in like open world environments. And so what I mean by that is typically with a robot, if you want to automate a task, you're going to constrain everything about that task and that environment you can. So if you want to pick up a water bottle, you want to make sure that water bottle arrives at the exact same location every single time so the robot knows where to position itself to pick it up. And so you want to just reduce as much variability in the process as possible because that allows for the kind of highest level of reliability for your robot to work. And the kind of beautiful thing about using neural nets for robotic control that are trained on data is they can adapt to variability. And you don't need to cover every possible edge case when you're building your robot because it essentially can adapt just like you as a human would adapt. You can look at the object and reposition yourself slightly if you need to pick it up. So that's half of it. The other side of it is controlling robots that traditionally would have been very difficult or impossible to control. And so an example of this is a humanoid robot, where you have a robot that has many degrees of freedom, many joints, hands are incredibly complex. And so kind of traditional control methods really wouldn't work if you wanted to be able to dictate how a hand should move to pick up an object. They would be like gross simplifications, but you couldn't get the human level dexterity that we have with our hands. But with this new method, we can basically take data of robots doing these types of tasks, and I can go into that more, how you got that data, but you can take that data, train a neural net, and you can now start to control complex robots like a humanoid or other robots that would have been impossible to control previously.
And so when you saw these trends, how did you think about, gosh, we could innovate here and then go find some places to point it over time? Or did you have specific use cases in mind and markets to tackle and then go deep in understanding those markets and work backwards? Like it seems like there's a bit of a chicken and egg thing in terms of, well, can the technology do it? And that's a whole set of time and resource to figure that out and to make it able to do it. And then there's also, but if we did it, for whom, and would they pay, and would they care, and would it matter, and could we do it in a way where the economics work and we can do it profitably over time? So how did you think about that chicken and egg in the case of Ultra?
Yeah, there's this like joke in the robotics industry where, just like people who want to build robots are just excited by robots, but they have the hammer, right? Which is the robot, and you're looking for nails. It makes sense and will result in like a healthy business. And the industry is littered with like dead robotics companies. There are many over the past couple of decades that have failed to build something that could address a wide enough need. So I guess I'll start by saying our fundamental belief is that there is a huge amount of just latent demand in the world for labor. And we as a society, I think we want to be ambitious with the projects that we take on, but often it doesn't make financial sense. We can't find the money to go and do these projects. We can't organize the labor, or it's too dangerous, or just people don't want to do these things. And so I think that if we could create essentially economical, scalable labor that was capable of doing a lot of the work that we as a society want to do, there's just going to be a ton of demand, like everything from building cities to what happens in factories and warehouses. So the question is like, how do you get from where we are today?
So does that presume that the laborers that build cities or work in factories, that those are not desirable jobs?
I think some of them are. My sense from talking to people in American warehouses and factories is there's a labor shortage. There are basically high churn jobs where companies are constantly trying to find people to come in and fill them, whether that's because people don't want these jobs or just literally the population is sufficient to fill these things. I think it's maybe a little bit of a mix of the two. But if you go into many modern factories and warehouses, the types of tasks that we have people doing are being reduced to very robotic tasks. Any like Walmart or Amazon warehouse has probably constrained people to stand in the same 5-foot radius and just do highly repetitive work, like packaging orders. I don't think these are great jobs. I don't think there are a lot of people out there who think to themselves, man, when I grow up, I really want to do this super repetitive, boring thing. But I also just think that, again, it's like hard to organize and find labor for all the projects that we want to take on, because it's also a question of economics and making these things happen for the price point that people can be paid at.
And so how much time did you spend looking at potential use cases and applications before anchoring and declaring either externally or even to yourselves that this company was a worthy endeavor?
Yeah, obviously we have a background in manufacturing, and we're not focused on manufacturing right now, but I think eventually it is an area that we want to grow into. My co-founder, Max, spent some time working. He was a consultant at BCG before we started Ultra. And so he spent some time working in the logistics space with USPS and Amazon Robotics, an auto store. And so we had some insight into that industry. And basically just one industry has grown a lot over the past, not just decade, but even during the pandemic, right? There was a huge surge of online ordering. And so all of these warehouses rapidly needed to scale and try to find people to fill roles. And in a way, it's an industry that has been most primed to adopt robots. Like when you think about like Amazon and their use of mobile robots that move around, like racking with products in them, even to robotic arms that are moving packages around. They're most commonly seen in warehouses. But that's really only true of the biggest players. And if you look at the rest of the industry, most warehouses have very little to no automation. And that just comes down to the cost and the challenge of integrating these systems and making them run day in, day out. And so that's how we ultimately landed on the logistics space as where we wanted to focus, and specifically order packaging for e-commerce orders. And so our robots today are packaging up orders that are getting shipped to your home when you place an order online for products.
And just from a timeline standpoint, when did the company start, and then what phase are you in today? And then it'd be great to work backwards to it's okay, if that's the phase you're in today and that's when the company started. Now fill in the whatever chapters we missed.
Yeah. So we started the company, we incorporated about 1 year ago.
Mm-hmm.
And when we
Okay,
got,
so still pretty recent.
correct. Yeah, still recent. Incorporated a year ago. We really only started on this direction about 9 months ago. When we started, it was actually from a place of getting the band back together. I had just left my previous job. I've reached out to my co-founders, Oliver and Max, and I said, guys, we should start another company. I think it's time. And once they were on board, we all agreed that we were going to dive in head first. That was about 1 year ago. At that time, we knew that we wanted to do something in the robotics space. We were still evaluating a number of different options. And in some ways, we were trying to avoid making the robots ourselves. From our previous companies, we knew how hard hardware is. And first, we were looking at some software-only ideas. We spent about 3 months talking to as many people in the industry as we could, which you always look back on this phase. I think when you're in it, it's frustrating because you just want to find the thing, right, and just start sprinting forward. But in hindsight, it was like incredibly important, informative, and even just the connections with a number of the people we spoke to have proven invaluable. So that was the first 3 months of the company. And finally, in about June of last year, we landed on our current direction. And yeah, we were just off to the races then, trying to start developing the tech and building our robots.
Got it. And what is it that led you to believe that building robots was necessary, given that you came in hoping that wouldn't be the case?
I think there were two problems we found when we looked at the industry as a whole and the potential to sell into the industry. First off, it's young, right? Robotics been around for a long time, but this kind of new model of a robotics company, it's really only been around for 2 years most. And there's just not a big market, or at least there wasn't a year ago, of companies that maybe we could build tooling or software for managing robots.
So a lot happening in the lab, but not a lot happening in the field.
Correct.
Yeah.
Now that was a year ago. Honestly, a year later now, it's been insane to watch. There's just been this Cambrian explosion of robotics companies, every kind of layer of the stack. And that is what we assumed would happen. And it's exciting to see that is happening. But even still, compared to other industries, it's still a small industry. A lot of the companies are very young, and they themselves are figuring out exactly what they're doing. And so I think it's tricky to try to sell into those types of companies. The other challenge that we found, and I don't know, this is just something about founders of robotics companies, or I guess I have some ideas here. It's hard to sell into robotics companies because most of them want to do everything themselves. I think this is changing. We're not actually doing this. We're using off-the-shelf hardware to build our robots. You go talk to many other robotics companies, and they are doing everything in the tech stack. They're developing their own actuators. They're assembling and manufacturing their own robots. They're building all of their software that they use in-house to basically control and manage their robots. And so we just kept facing dead ends when trying to talk and sell to these companies. And yeah, ultimately we wound up at a place where we just realized if we wanted to do something in this space, we were going to have to like build the robots ourselves.
And where are you today? How far have you gotten?
We've gotten what I would say surprisingly far. I'm surprised myself. We spent the first few months of the company purely focused on the AI side of things, given that was the most recent breakthrough and in some ways the least mature tech stack. We really wanted to convince ourselves that these new AI control methods were were actually capable of doing the things that we wanted to do. And so we spent a few months like purely focused on research and evaluation, where we were using hardware and recording data with that hardware and training our own neural net models, and then just like making sure that like, do these actually work? Can we actually get a robot to do a task reliably with this new paradigm for control? And the answer was yes. We convinced ourselves and we could do that. And yeah, we spent the first 3 months doing that. We actually went through Y Combinator over the summer. We were out in San Francisco for 3 months. We're based in New York. We live in New York now, but we moved everyone out to SF, including my family.
Wow.
That was a whole sitcom type experience, but kind of fun. And yeah, so we went through Y Combinator over the summer. Coming out of that, we raised the seed rounds in September. And then we came back to New York, and the focus shifted from kind of the AI side of things to let's actually go build and deploy these robots and validate the customer demands for this type of product, validate that we can build a robot that can actually do this task in a way that is attractive in terms of the cost and the throughput. And yeah, since the fall, we've deployed now multiple robots that are operating in our customers' warehouses and are packaging orders every single day. It's like an insane timeline, in my opinion, for developing and deploying robots. But I also think it's like indicative of kind of the point we're making, which is existing hardware is good enough to build these types of robots. And majority now of the work to do and of the value to create is actually in software and just like deployment of these systems and getting them to work well for customers. And so that's really where we're spending most of our time.
And what types of customers are you focused on? Who do the buyers tend to be within these organizations, and how do they tend to be doing these tasks today?
So we are currently selling into the logistics industry and to 3PLs, third-party logistics. These companies, they're the companies that make the American logistics industry work, right? So they receive inventory, often coming from overseas. They store it and move it around between warehouses. And then when you place an order online, someone or a robot sometimes in the warehouse goes and grabs that product, puts it into a bin, kind of has your information linked to it. And eventually at the end of the process, a human today is standing at a workstation and takes those items that you've ordered online and puts them into a poly mailer or a bubble mailer or a box, and that gets shipped to you. And so, yeah, 3PLs are companies that do that and much more, honestly. It's a huge industry. We're selling to those companies today. They vary in size. They're the super large players, including the DHLs and FedExes of the world, but it's an incredibly fragmented industry. And so there are also a lot of companies in the mid-market or smaller end of the market who are almost regional and serve specific areas within the United States or have specialties in terms of the types of products that they store and ship. And so those companies, including many of the large players, this is entirely unautomated, and they have people today standing stations and packing up orders. And so we're currently selling them robots to help basically augment those people that they have doing this and help them just scale as the industry grows.
And what function and level of person do you find is the best entry point so far? And what's the pitch?
Yeah, it depends on the size of the company and the type of the company, how technology innovation forward they are. So far, we've had a lot of luck with smaller to medium companies going directly to the business owners or the kind of C-level team. But as the company grows, you'll typically see innovation or automation department. And so there are people who are constantly thinking about how do we identify, try out, eventually scale like new innovative technology solutions that can help us. And those teams are our go-to when you're talking to companies that have them. But a lot of times they don't exist. And so you're either talking to, like I said, the business owner or kind of the head of operations, who's the one who needs to figure out like, how do we actually get our packages out the door on time every single day, 365 days a year in some cases. And so the pitch is really about helping them have reliable, affordable, scalable labor, right? As I mentioned before, it's very common to talk to people who run these businesses and hear that they are having a hard time basically getting workers in the door to fill the demands that they're seeing from their customers. And so the benefit of a robot is consistent throughput. So you have a robot or multiple robots in your warehouse and you know that they can do X thousand packages a day. You can rely on that 7 days a week. And that's really the main pitch there, beyond the kind of ROI that we're trying to hit and increase over time, which just comes down to the cost of our robots and their operation, and then the throughput that they have. So how many packages can we pack an hour?
And do you find, are they seeking augmentation to fill unfilled seats? Are they thinking replacement as it relates to humans? And I guess I'll ask this both in terms of the short-term aspiration, but also their long-term aspiration to the extent that they're thinking about and talking about that.
So we have not seen any of our customers replace any of their workers with our robots. This has, at this point, has really purely been an augmentation strategy. Our customers are all growing. Like I said, this industry has been growing for a long time now. And I don't think that's going to stop anytime soon, especially we can talk about the tariffs more. The tariffs have also meant that like more fulfillment is now being done in the United States as opposed to in our neighboring countries or overseas. And all of our customers and all the companies we talk to are trying to scale to meet this demand. And really the way we see this carrying out is that these robots are additional to the labor that these companies already have. In some cases, I think it's also about shifting labor to more like useful, like well-suited areas within the warehouse. And so, for instance, one of our customers has bulk packaging operations. And these are like products that they just ship many of every single day. And so they would have people who were just like in the back of the warehouse, just like constantly packing the same exact thing over and over again. It's a task that no one wants to do. And they'd rather be doing things that feel like they can actually flex their like human skills a little more. And so as we've taken on more of that bulk packaging, those people have been freed up to basically do other things within the warehouse, like focused on optimizing the inventory within the shelving and packing orders that are a little more complex and require more of the kind of human skill.
And just from an effectiveness standpoint, how does the robot compare to the human packer? And from a cost standpoint, how does the robot compare to the human packer? And then what do you think will happen directionally as Ultra and as the category matures?
Right now, in terms of performance, our robot is subhuman. We cannot pack as fast as people do. People are amazing, by the way. The human body is amazing. Our ability to move quickly, but without breaking things, to respond to our environment through vision and what we hear and touch. It's like the more you get into building robots, the more you just appreciate how amazing the human body is and how it's evolved. So yeah, with that said, we're not at human level in terms of like packaging speeds right now, but we're not that far away. We have our robots, we pair with other hardware, basically supports the packaging process and means that like we can get to like pretty high speed. Recently, we hit about 200 packages an hour. Now, like when you think about speed, it also depends like what types of orders you're packaging. Are they orders that have a single item or multiple items? Or are the items relatively small and easy to grasp and pack? Or are they large and floppy and maybe you need to fold them to fit them into the bag? So all of that is going to affect your throughput. We've only been doing this now for 9 months. And so we haven't spent a ton of time on the actual optimization of that process. We see a lot of opportunity to go and improve the speeds here. And that's really going to come through trial and error. So doing more of this means that we can collect more data. And the more data we have, the more we can optimize our neural net models to make them better and faster. In terms of cost, really, we're trying to come in about the same cost as a single shift worker. But then the idea is that you can run the robot for multiple shifts. And if it is equivalent for one shift, you can now take it and have it run instead of just 8 hours a day. You can have it run for another half shift or another full shift. And so you get a lot of value out of it the more you run it. And our goal is to basically enable our customers to run more than they were running previously. So get more utilization out of not just the robots that we're selling them, but like their entire warehouse. And at the end of the day, the challenge there always comes down to labor.
And given what you know after so many years working in robotics, and also just how quickly things are evolving in the category over the last year, as you mentioned, if you were one of these human workers, would you be scared? Would you be excited? Because and I asked because, I mean, I talked about this when Hadley Harris came on the show. It came up about jobs and stuff. And it's, look, on the one hand, there'll be a lot of shifting. And when there's shifting, there's change. And then some segments can suffer or need to reskill or whatever. But then it can be curing diseases. It can be like, there's all these societal benefits that are unheralded. And you can't discount the benefit too. You can't just look at the negative. But I'm just, I guess, trying to level set, like, how much change will be coming and what will the implications be for these workers, with the understanding that whether there's change or not for these workers, that doesn't mean it's necessarily bad or shouldn't happen.
Yeah. The response so far from the teams that we're working with has been pretty overwhelmingly positive. And I think that's because for these teams, like, they view this as a way to like boost their productivity, not just the individual productivity, but like the company's, the team's productivity. Mm-hmm. If you walk into most of these warehouses, they're overwhelmed pretty much every single day. There's always the clock running. We need to have these orders packed by whenever they get picked up in the afternoon. And it's just like day in, day out. So they want whatever help they can get to take a little bit of that burden off of them. And like I said, I've now stood at these stations and packaged orders myself. And I don't view this as a great human opportunity. It is incredibly repetitive. It's exhausting. You're standing feet all day. Your knees start to ache at the end of the day. Do I think that like long-term, there may be some like job loss in this specific space? Probably, just like there is across all automation when we figure out a way to go and replace some highly repetitive process with something that's a little more economical. And yeah, at the end of the day, I think this is a larger question that's obviously I need an opinion here, but we all need to think about, which is how do we retrain people for the types of things they are uniquely well suited to do? Which, by the way, I think there's an incredible amount of opportunity out there.
And I guess I'll ask a little bit of a different question then. What is standing in the way of the robots doing this full function today, and how long do you think it will take for us to get there?
So just to give an idea, like I have 2 daughters. One is 6 months and one is 3 years old. And it's really interesting to watch kids develop in terms of their physical ability, right? Their ability to respond to the world, to reach for things, to eventually grab those things, to manipulate them, to bring them to their mouths or control them, and eventually to do things that are a little more complicated and dexterous. My 3-year-old, it's exciting. She's now able to start playing. We have a card game and she can pick the cards off the top of the deck pretty well right now, but she doesn't get it every single time. And when I think about the progress we're seeing in robotics, like maybe a good way to think about it is to compare it to like the development of a child. Cutting edge robots today in terms of like dexterity are still in the 6 to 12 month age range, where maybe they can grab items and you can reorient them a little bit to put them into a different location. But there's so much that we're not able to do, both at the software level and at the hardware level. Like even just having robot hands or end effectors that have the finesse to be able to use small tools or reach behind areas where they can't fit. Again, going back to what I was saying before, I think that there's just like going to be a ton of opportunity for people to learn how to do things that robots won't be able to do for a long time. But it may require some retraining and some new skills that people don't have. And I think that's in many ways one of the things that we should be focusing on as a society is how do we do more of that?
And so, I mean, if you play out, call it the next 12, 18, 24 months for Ultra, it seems like there's different ways you could go. You could just figure out how to scale the things you're already doing and serve a higher percentage within each facility, but also serve more facilities, more customers. You could take on more tasks within these facilities than just the ones that you started with, or you could also expand to different kinds of facilities and different kinds of use cases over time. How are you thinking about staging and phasing, and what are your key priorities?
At this point, we are focused singularly on this one task. We believe startups, you need to have a deep focus and do whatever you're doing really well. So we're in the near term purely focused on order packaging for e-commerce fulfillment. Our focus on our strategy is to basically deploy as many robots as possible, because with more deployed robots, we're generating more data. And like I said before, we believe that really the key to providing increasingly valuable and capable robots at this stage is going to be about the data that you can collect and generate and use to train your AI. In the same way that we've seen over the past couple of years, LLMs scale up and become more capable, and now they can do images and video and audio. That same type of scaling is going to apply to robotics. And so again, the more robots we have out in the world that are collecting a variety of diverse data, grabbing different types of items in different warehouses with slightly different process, all of that's going to enable us to build the most capable packaging system. And then at some point, a few years down the line, we'll take that and then we'll move it to the next area in the warehouse where we think we can add a lot of value, of which there are a number of other tasks have a similar type structure where there's a person standing in a single spot, moving items from one location to another. And so we want to position ourselves to slowly increase to like those types of tasks over time.
How do you think about competition and defensibility?
Yeah, at the end of the day, I think this industry, this opportunity is so incredibly large. It's not going to be winner take all, at least for a long time, and hopefully never, right? Because even the idea of winner take all in the space is scary. Otherwise, when we think about like defensibility, it's really about owning the relationship with these customers and then having robots that are operating in their warehouse, like I said, generating data. I think that there's a large challenge to taking a robot and putting it in a customer's facility and getting it to work day in, day out, providing positive ROI. And once we have a robot in the warehouse, that also then increases the chance that customer is going to want to work with us for their next robot and the next one. And so I think our product or service is very sticky from that perspective. And so, yeah, at this point, we are trying to, one, just grow into our current customers, but then also go and start building relationships with other companies that we see a lot of future opportunity with. And as we have more robots, that kind of then grows the size and the rate of the flywheel. More robots creates more data makes our robots better, and our robots being better means that we can sell more robots.
As I've been investigating, it seems like again and again, what I'm hearing is launch early and then turn your customers into source of data that can train the model. And that way you're training the model over time based on real customer data versus just stuff you can grab here and there from random places. And it'll get you more bulk and also just better data. When it comes to training the model or training the neural net, as you said, is it the same skill set that does that across data types and data sources and across industries, et cetera? Or is it wildly different? And what is that skill set?
Do you mean so different from training, let's say, like a language model? Or
Yeah, or like Swapnil, the founder of a company called Swing Vision, using AI for racket sports, and he was talking about how, yeah, they grabbed some data of clips of people swinging and stuff, but that once they were in market, then the data was flooding in, and it was from all the people that were using the app. And so that is, I would imagine, a very different kind of data and model training than robotics for e-commerce fulfillment. But that's what I'm asking. Those are just two, but I'm sure we could just spitball and talk about dozens of different use cases and industries and data types. But is it the same sport in terms of training the model, or does that sport vary widely?
generally, there are a lot of similarities. And someone who is training a model to help people improve their racket sport game or predict where the ball might be going. A lot of similarities between that and what we're doing in robotics. We're using methods that are called like imitation learning. And so you take a bunch of examples and then you basically try to teach your robot how to imitate those examples. In terms of the data and what it looks like compared to these other types of models, the tricky thing with robotics data is, first off, like there isn't much of it, right? There's no internet of robotics data out there like there was for GPT-1. And therefore, it needs to be created. And so the main method that most robotics companies today are using to create that data, it's like a chicken before the egg problem, right? If you don't have the AI to control the robot, so like how do you then deploy the robot to generate the data that you need to train the AI? The way we are doing it is with what's called teleoperation, where essentially we are remote controlling our robots to actually do the work. And so someone is in real time using, we have a few different pieces of hardware that we use to do this, but they are acting as the robot actually doing the task. And so it's essentially a way of bootstrapping the robot, the product, the relationship with the customer that also then generates the data that we need to automate this. So that is the kind of most, I'd say, tried and true and common way to generate this data today. There are some other methods like using simulation to basically create simulated environments where your robot can also do the task and then create that data. But for these types of manipulation tasks where you're picking up objects and moving them around, simulation doesn't work as well as real world data because it's just very hard to model all of the intricacies of friction between our hands and the objects, and the world we're interacting with. So that's something that the research industry is definitely focused on and looking towards. But like teleoperation today is certainly the most common in what we're using.
It almost seems if there was a way to not just benefit from the data that you're generating, but from the data that everybody generates around these use cases, then the whole ecosystem would evolve faster. But it also seems if the data is the moat, then everyone's going to want to be territorial about their data and not share it. Are there any initiatives around sharing, or is it very much kind of a hoarder mindset around these data sets as they're emerging?
Yeah, it's a great question. So there are initiatives, basically like open source data sets or projects where people are trying to share data. And it's both at a kind of like an academic research level. Many universities and research labs have undergone efforts to collect a bunch of data, and then they'll open source those data sets in hopes of other labs leveraging them as well. And then there's a really cool, it's more than a project at this point, Hugging Face, right? That kind of open source AI company has a team called Le Robot that is focused on building open source tools and models and data sets that anyone in the world can use to basically, if you want to try to build a little robotic arm and train it to do a small task, you can now do that much more easily than you could have just a couple of years ago. And part of their hope, I think, as an organization is spurring a little bit of a global effort to actually generate a lot of data that could be used to train better and better robotic foundation models. And then there are companies, not us, but there are other companies out there that are almost trying to be the open AI for robotics. And so these companies are focused on training general purpose foundation models for robotics. And so they themselves are investing a lot in collecting a massive amount of data on robots that they can use to train their own models. In many cases, they're also pairing the robotic data with other data like vision and language models, because they don't want to just have the robot know how to control its body, but they also want robots to be able to accept instruction and reason about the subtasks that might be required to complete something. And so they're using vision models and language models in conjunction with robot data to train what are called vision language action models. And so these are models where you can basically give the robot a task. Hey, robot, can you put the dirty dishes on the counter into the sink? And the robot can then take that task, look at the world, interpret the world, break down that kind of top level task into a number of smaller steps that it needs to complete. And then for each of those small steps, it calls the robot portion of the model, which is trained on all of the physical manipulation data, actually go and execute the moves that are required to do the task. And so that's the most like cutting edge in terms of like building the equivalent there. Those companies are going for the chat GPT of robotics. And I think that's going to happen at some point and is exciting. We at Ultra are a little more focused on getting one specific use case to work really well. And so that's why we're just focusing on a single thing right now.
And in order to get the widespread customer adoption, how much of it is technological innovation versus comfort level awareness, behavior change to technology that is already ready for prime time? Like, how big is the lag between the technology readiness and the societal readiness?
First off, there are many robots in the world today, right? If you think of a robotic arm, there are many robotic arms deployed in warehouses and factories. Not as many as you think or would hope. And so the question is, why aren't there more? And ultimately, our belief is that comes down to the costs being too high and it being too challenging to get these robots to do the things you want them to do reliably. And so that's where this new kind of technological wave we think is addressing. In terms of the barriers for adoption here, I think right now there are a number of parts of this tech stack that are still like fully mature. And most customers don't want to buy science projects, right? You want to buy a solution that you know is going to work, that you know is going to have a kind of defined positive ROI. You want to tell the team to come in, install it, and then like you're good to go. And again, at Ultra, we're focused on getting to that point as fast as possible. In fact, I think we've already gotten there. Other companies are a little more kind of like deep tech research focused, where they may be on 5 or 10-year trajectories. But at the end of that, the hope is that there's some like massive innovation and unlock where all of a sudden robots can just do anything you want them to do. And that may happen. But in our view, the majority of the work right now is on the actual like deployment and how do you make these systems solve a problem for customers and not be a burden instead.
So if you think about the mode that you're in now, what are you most worried about, or what's the hardest part?
What's the hardest part? Aside from everything, right? Building a company is generally challenging. Scaling up the team, finding customers, deploying systems to those customers, or building the right product. I'd say right now we're in the phase where actually, a lot of things are going right for us. It's a very exciting moment. Honestly, like I'm having a ton of fun, which that's when you know that like things are going well. But we have too much going on. And so right now we're also trying to, I'd say like very strictly prioritize the most important things. I think as an early stage startup, like you can't afford to work on more than the most important. And so for us, I think that really comes down to deployments. So how do we deploy? I'd say we're going to order of magnitude increase the number of robots that we have deployed in the world by the end of the year. With that, there's a lot of work on making sure that these systems are as capable as customers need them to be, have the ROI that customers need them to have. And every additional robot we install in a customer's warehouse needs to be easier than the last one. And so that is both an engineering and an operational challenge for us.
And I'm sure there's a number of those engineering and operational challenges that are within the purview of your control and your charter. If you step outside of that, what are some problems or changes that are outside of the purview of your mandate that, if they came about, would be most beneficial to accelerating your progress?
I think that really any progress at the AI level is beneficial for us. If tomorrow there was some major breakthrough in the type of model that people are using for robots that made these models much more performant, they are faster, they're more reliable, or maybe that made them more data efficient. Instead of needing 10,000 examples, maybe we could just use 1,000 and you get a system that's just as good. We would be able to immediately leverage that. And again, every robot that we have deployed, we could then go and take these models and start running them on. And I think that is also, when I look at the overall AI industry beyond just robotics, that's how it seemed for most companies building non-robotics AI. Every time a new company comes out with the next model that's just like even more capable and has some new features, sure, if you're building like a small little feature that's just like a part of ChatGPT, then you're probably going to get run over. But otherwise, I think it's just been this amazing tailwind for most companies building in this space. And I think that will be true for us as well.
And if you think about the long term, if you're successful beyond your wildest imagination with Ultra, what does it look like at that time and what have you achieved?
Yeah, that's something that is, I'd say, a continuously evolving vision for us. Really, we want to build what I would like to call like utility robots. Imagine our robots, they're not the main character in the story. They're the droid operating in the background that's actually just like doing the nitty gritty hard work that enables a functioning, amazing society. So we want to have a robot that can address a lot of different tasks in different types of environments and really just works out of the box. And so it's something that can be ordered, shipped to a customer, opened up, and easily just like starts getting to work and adds value. I think when we as a society have something like that, Again, like it's going to benefit all of our kind of like core production infrastructure. And so we're trying to get to that as fast as we can. And there are big challenges, both in terms of the software and the AI, and in terms of the hardware and getting the costs down and getting these systems to be reliable. But the good news is it's not just us working on it. There are now many incredibly smart and motivated people and companies working on this. Going back to why we chose to start this company, I think it's just an area where we're going to see insane progress over the coming years. So I really wouldn't be working anywhere else right now.
I can hear that in your voice. Is there anything I didn't ask that you wish I did, or any parting words for listeners?
I think we covered it all. Yes, a lot of great questions. Again, thank you for having me.
Of course. And I guess the last one is just anyone you want to hear from. Yeah. For anyone listening that's inspired by your work, are there any specific hires that you're trying to make, or customers you want to hear from, or just, I don't know, like your chance to shout out anything that's helpful for you.
Absolutely. So we're hiring engineers right now. We're hiring people to work on the machine learning side of our tech stack and also on the robotics side. So if you're someone who is excited by what we're doing and fits into kind of one of those two broad categories, we'd absolutely love to chat. We're based in New York. We're an in-person company. We're a small team right now, move fast. And there's a real opportunity here to join at the ground level and have a big impact. And on the kind of customer and industry side, if you are currently running or work at a 3PL or a brand or a retailer that does your own fulfillment, and you're interested or curious or have a strong opinion about what our product should look like and what our roadmap should look like, I'm always excited to talk with people who just want to nerd out about the logistics space, and happy to share more about our robots. Would love to get in touch. Our website is ultra.tech. My email is jon@ultra.tech. And please reach out.
All right, Jon, thanks so much for making the time. I learned a lot. It's fascinating what's happening in robotics, especially at the intersection of robotics and AI, and looking forward to tracking your and Ultra's progress in the future, and wishing you every success.
Thanks so much, Jason. I appreciate it.
Thank you for tuning in to The Next. If you enjoyed it, you can subscribe from your favorite podcast player. In addition to the podcast, which typically publishes weekly, there's also a weekly newsletter on Substack at thenextnext.substack.com. That's essentially for weekly accountability of the ground I'm covering, areas I'm tackling next, and where I could use some help as well. And it's a great area to foster discussion and dialogue around the topics that we cover on the show. Thanks for tuning in. See you next week.